Black holes are quite literally a mystery to us. We know them from movies as vortexes of mass destruction, as in this image. But in reality, black holes are so much more and stranger than just fiction. Okay, just a show of hands of who knows how black holes really work. Not very many, but I thought. I'm not saying I do know everything about black holes, but I know a lot about them. And I want to share this with you this afternoon. So let's get on with the basics so we can get to the interesting stuff. Who, when, and how. John Mitchell theorized the existence of black holes sometime between 1783 and 84, but their existence wasn't confirmed for another 200 years. But that's all boring trivia. There's nothing boring about black holes. In 1971, scientists, for the first time, took an X-ray photo of where they believed the black hole would be and saw two massive radiation beams radiating away from what they concluded could be nothing other except for a black hole in the process of devouring a massive star. That was an indirect observation, but it was big enough to persuade the American scientist John Wheeler to call the phenomenon black hole. And that's what stuck. Now, as we talk, for the first time, scientists are taking a real photo of of a supermassive black hole at the center of our galaxy. The photo of this black hole should be published in the next few months. I can give you a link to the scientist's website after my talk if you're interested. But that's all about what a black hole is. But how did they form? This part will get crazy. This is a red supergiant. They're the biggest types of stars out there. The one in my image is only 4 times the size of our sun. Tiny by red supergiant standards, but pretty big nonetheless. Now, the supergiant's life is caused when the fuel being burnt by the star, mostly hydrogen and helium, runs out, and the lighter elements are fused into massive amounts of iron that build up at the core. As the iron builds up, the fusion that holds the star together becomes unstable, causing the star to begin collapsing on itself. The process of collapse is unavoidable. It happens incredibly fast. In fact, the star collapses on itself 1/4 the speed of light into something of an infinitely small size, less than an atom in diameter. Let that sink in for a second. Something 4 times larger than our sun shrinks to something of infinitely small size. This is known as the singularity, a point that's infinitely small and infinitely dense. Around the singularity, something called the event horizon forms, and around that, an accretion disk. Now, if things weren't strange enough already, this is where they get really, really weird. Gravity is a relatively weak force. Something can come quite close to a black hole without actually falling into it. Something can come to the event horizon of a black hole, but if it falls within the event horizon, there's no return for anything, not even light. Now, this is really interesting. Because if not even light can escape a black hole's gravitational force, then how do black holes die? Do they die, or will they just keep growing, consuming the entire universe and everything in it? No, they do die, through a process called Hawking radiation. Discovered by Stephen Hawking, the guy from my sister's race earlier on this afternoon, Hawking radiation is a slow process. And when I mean slow, I mean they could take a Google years for black holes to die. But to understand this, we have to look at the universe on a quantum scale. Everywhere, the virtual particles are constantly annihilating each other out of existence. When this happens at a black hole's event horizon, one of the particles is eaten by the black hole, and the other one escapes, becoming a real particle, stealing some of the black hole's mass to do so. This process speeds up during the life of a black hole. At the mass of a nickel, the black hole died in a blast that would make all nuclear bombs that ever existed on Earth nothing more than a grain of sand on the largest beach you can imagine. This is why I've chosen to speak about black holes today. Because black holes are some of the strangest things out there. Because I've always been fascinated by space and astronomy. Because they seem stranger than fiction. In fact, how many times do they play a part in a movie or a film that you've seen? And as strange as the movies make them seem, they're even stranger, bringing together the pillars of quantum mechanics and physical space and relativity. The fact that we're going to see real photographic evidence of something that seems too strange for reality is overwhelming. It's reminding us all of the beauty of the universe that we live in. Thank you.